Hello there, and welcome back. Tonight we step into a time long before humans, mammals, or even dinosaurs graced the Earth. The air is thick with humidity, and the sky above glows softly with unfamiliar constellations. You find yourself drawn into a world that is both alien and strangely peaceful, a world teeming with life, but only beneath the waves. Land lies mostly empty, save for the gentle rustle of primitive plants and the occasional scuttle of ancient arthropods. But below the water's surface, something incredible is happening. In this mysterious age, creatures of dazzling form and fierce power begin to take their place as rulers of the oceans. Tonight we'll follow them, one gentle step at a time, through the world of the Devonian period, a time often called the Age of Fishes. Let's begin our journey far back in time, just before fish took their crown. You step into a world where time itself feels heavy, roughly 419 million years ago. The Devonian period has not yet begun. Instead, you find yourself at the twilight of the Silurian, a predecessor period where life has made some bold first attempts to leave the sea. But the land is still largely quiet, bare, and lifeless compared to what you know. No birds sing, no mammals scurry. Instead, the terrain is mostly rock and sand, interrupted here and there by mosses and liverworts, small green pioneers clinging to survival. They hug the edges of ancient shorelines and riverbanks, their simple structures straining upward toward the muted sun. The air you breathe, if you could breathe it, would feel different. Oxygen levels are far lower than today, and carbon dioxide hangs heavily in the atmosphere. The sky has a soft bronze tint, as the filtering power of dense forests has yet to evolve. Winds whisper across empty plains, stirring the surface dust into ghostly spirals. Occasionally, you might spot something move. An early arthropod, perhaps, like a millipede-like creature, or a scuttling eurypterid that ventured onto land for a brief moment, testing the possibilities of a new frontier. But the real drama of this world lies below the surface. You follow the sound of water and find yourself at the edge of a vast, shallow sea. These inland seas stretch for hundreds of kilometers across continents that look nothing like modern Earth. The supercontinent Gondwana dominates the southern hemisphere, while smaller landmasses, Laurentia, Baltica, and Siberia, float elsewhere, slowly converging through the steady motion of plate tectonics. The seas are warm, relatively calm, and nutrient-rich, perfect for life. If you wade into the shallows, the water is clear but full of movement. You might see colonies of algae swaying in the currents, and sponges filtering water in their quiet, efficient way. Coral-like creatures are already beginning to form rudimentary reef systems, creating safe havens for smaller marine life. Brachiopods lie nestled in the sediment, their hard shells clamped shut. Crinoids, creatures that resemble flowers but are very much animals, anchor themselves to the sea floor, their feathery arms extended like celestial dancers. Among these early reefs swim jawless fishes, the agnathans. These creatures look strange to your eyes. Their bodies are long and soft, some covered in armor-like scales, others bare and eel-like. They move with slow grace, propelled by undulating fins. Without jaws, they feed by suction or by scraping food with specialized mouthparts. Yet for all their limitations, they've ruled these seas for millions of years, adapting to various environments and paving the way for what is to come. Near the seafloor, trilobites scurry about, arthropods with segmented bodies and faceted eyes. They look almost like little armored submarines. Some are scavengers, while others are predators, carefully navigating the cracks and crevices of coral outcroppings. Nautiloids, relatives of today's squid and octopuses, drift silently by, their coiled shells gleaming like ivory against the blue. They extend their tentacles to grasp prey with both grace and precision. And yet, despite all this life, something feels poised to change. In the fossil record, subtle shifts are taking place. New species begin to appear with rudimentary jaws. These early jawed fish, still rare, represent an evolutionary innovation that will soon revolutionize survival in the sea. With jaws come possibilities, stronger bites, new diets, better defense, and more efficient hunting. You linger for a moment longer on this ancient seafloor, watching a delicate ballet of life play out in slow motion. The silence is not empty, it hums with potential. The stage is set for an explosion of diversity, color, and form, unlike anything the Earth has ever seen before. In the next chapter of Earth's story, these seas will become cradles of innovation. Fish will grow teeth and bones and armor. Some will become swift swimmers, others lumbering giants. The Devonian dawn is approaching, and with it, a time when the oceans will be ruled by an astonishing parade of evolutionary marvels. You remain at the edge of the ancient sea, letting your senses absorb the rhythms of a world in slow but profound transformation. Beneath your feet, the very crust of the earth moves, not with violence or eruption, but with patient, imperceptible motion. The continents, though not yet formed into the familiar shapes of today, are drifting, colliding, and reforming, sculpting new environments and rearranging the paths of ocean currents. It is the Devonian period now, about 419 million years ago, and the planet is busy at work. The geography of this world is unlike anything you recognize. To the south lies Gondwana, an enormous supercontinent that dominates half the globe. Its rocky coasts stretch endlessly, flanked by wide, shallow continental shelves that cradle inland seas. These seas are warm, teeming, and remarkably clear. Sunlight pours down through the upper layers of water, fueling blooms of plankton and microscopic algae. Farther to the north are smaller, drifting continents like Laurentia, Baltica, and Siberia. They are slowly, ever so slowly moving toward each other, destined to collide and eventually form the ancient supercontinent of Euramerica, or Old Red Sandstone Continent. You watch this grand tectonic ballet unfold not in bursts, but in the glacial pace of geological time. Mountain ranges begin to rise where plates push against each other. Sediment worn from newly forming highlands washes down into rivers and estuaries, feeding the expanding marine ecosystems. These mountain chains, like the nascent Appalachians and Caledonides, will someday grow mighty, towering across the face of the earth. But now, in the Devonian, they are still young and growing, and in the seas that spread like fingers between these continents, something beautiful is happening. The shallow waters, sun-drenched and nutrient-rich, act like giant incubators for life. Coral reefs expand dramatically, forming some of the largest reef systems in Earth's entire history. These Devonian reefs are not made by the same corals we know today, but by stromatoporoids and tabulate corals, ancient reef builders whose skeletons rise in rounded domes and clustered columns. With every generation, their skeletons pile upward and outward, building intricate cities of stone beneath the waves. Within these reef networks, the water is alive with movement. You float over a world of caverns, ledges, and canyons, where early fish dart among shadowy overhangs and sunlit pools. It is here, in the embrace of these reefs, that some of the most significant evolutionary experiments of the Devonian begin to unfold. Water temperatures vary by region, but in general, the climate is warm and stable. There are no polar ice caps, and the sea level is high. This creates broad, epicontinental seas, shallow oceans that blanket the interiors of continents. These seas are not only home to marine creatures, but also act as highways for their dispersal. A species born in one corner of the world can, over generations, spread to another, carried by slow currents and migrating tides. Above the surface, the sky glows in hues of soft gold and lavender. The sun, unfiltered by today's ozone-rich atmosphere, casts a diffused light that seems to bathe the world in a constant twilight. Clouds drift lazily across the horizon, their reflections rippling across calm waters. Occasional storms brew over the open seas, but they are slow and heavy, bringing rainfall that feeds the early plant life, edging the coasts. You walk the shoreline of one such sea, your feet sinking into soft, silt-laden sand. The ground is dotted with early plants, simple stems with no leaves, no flowers, no seeds. Yet they are alive, breathing, photosynthesizing, and beginning to alter the world. These primitive land plants, like Cooksonia and Rhynia, are among the first to establish true vascular systems. They drink from the soil and send nutrients through their bodies, enabling growth and spreading spores to new terrain. Their quiet presence marks the beginning of Earth's greening. And in their own quiet way, they begin to shake the planet's atmosphere. As they grow, die, and decay, they lock carbon into the soil and slowly contribute to rising oxygen levels. The changes are subtle, but their long-term consequences will be enormous. Below your feet, tectonic forces continue to mold the world. Ocean basins deepen, continental shelves widen, and volcanic activity pulses along mid-ocean ridges. The interior of Gondwana experiences massive mountain-building events, while Laurentia and Baltica edge closer together, tightening the embrace that will create new land masses and isolate seas. All of this planetary motion is invisible to the creatures that swim the reefs and shuffle along the sea floor, but it shapes their world nonetheless. As new basins form, they create new habitats. As mountains rise, they influence weather patterns and sediment flows. The Devonian Earth is a world of subtle upheaval, quiet from your vantage point, but dynamic at every scale. From a global perspective, Earth is warming slightly during the early Devonian, then begins to cool toward its middle stages. These temperature swings affect sea levels and climate zones. Coral reefs retreat and return, expanding and contracting with each shift. Yet life continues to find niches, adapt, and thrive. The world you stand upon is in motion, not just geologically but biologically. Evolution is accelerating. The stage is being set for something extraordinary. In the next part of our journey, we'll leave the shifting continents behind and dive beneath the waves, where Devonian seas pulse with life, color, and innovation. You'll see a world in bloom, where creatures of scales, gills, and bone begin to tell one of the greatest stories ever written beneath the waves. The warm light filters gently through the clear, shallow waters, painting the seafloor in a mosaic of dancing gold. You drift now in the heart of a Devonian sea, far from the rocky coasts and the whispering wind of the land. Around you, life moves in a slow, rhythmic current, a living tide of motion, color, and soundless activity. This is no ordinary ocean. This is a cradle, a nursery of complexity, a realm that has become, in this ancient time, Earth's most vibrant laboratory of evolution. These Devonian waters, stretching over what would one day become Europe, North America, Asia, and Australia, are filled with nutrients, carried down from rising mountains by rivers and scattered through the seas by tides and coastal upwellings. The nutrients feed plankton, and the plankton feed countless creatures in turn. It is a time of abundance, and from that abundance, a stunning array of life begins to emerge. You float through coral reef gardens more immense and more intricate than anything seen before or since. Towering mounds of stromatoporoids and tabulate corals rise like underwater fortresses. These ancient reef builders are not like today's stony corals, but they play a similar role, constructing the architecture of the underwater world. Between their branches and hollows, 1,000 dramas unfold. Small armored fishes dart between coral arms, quick, jerky bursts of movement that vanish in a blink. These early fish, many jawless, are joined now by new kinds, jawed fishes with hard skulls, flexible spines, and powerful tails. Some are covered in protective plates, others glimmer with scales as fine as spun metal. Their eyes, large and glassy, scan the terrain with curiosity and caution. A group of trilobites marches over a coral ledge in perfect procession, their many legs paddling rhythmically. They filter the sand for food, their segmented bodies casting shadows on the reef floor. Above them, delicate crinoids sway in the water like plants. Though they are animals anchored to the reef, filtering the passing currents with their frond-like arms. Near the surface, sunlight warms the upper layers, drawing algae into frenzied bloom. Microscopic diatoms and cyanobacteria form great clouds of green and blue, invisible to the eye, but essential to the life web. Tiny creatures called zooplankton graze on them, and in turn become prey for small fish and larger invertebrates. You follow a school of early bony fish, each no longer than your hand. Their sleek bodies shimmer with iridescence, and they move as one, turning, darting, and spiraling in perfect unison. These are the ancestors of modern fish, ray-finned and lobe-finned pioneers whose adaptations will shape the course of vertebrate history. Their bones are forming within, light, strong, and flexible, offering structure without weight, a revolution in underwater engineering. In the deeper waters, far beyond the reach of coral reefs, new forms thrive in the shadows. Strange fish with blade-like teeth and thick scales glide by, their eyes adapted to dim light. Some flash bursts of bioluminescence, while others rely on slow movement and ambush to catch prey. The diversity of body plans is astonishing. Long snake-like swimmers with ribbon fins, flat bottom-dwelling feeders with vacuum-like mouths, and predators with jaws strong enough to crush armored shells. Not all fish rely on speed or stealth. Some, like the great placoderms, dominate through sheer presence. Their bodies are massive and heavily armored, their jaws lined with sharp, bony plates instead of teeth. These giants patrol the open waters and reef edges, moving like ancient battleships. They are both feared and admired, and their rise marks a turning point in marine evolution. The oceans of the Devonian are also a place of interaction and interdependence. Cleaning fish pick parasites off larger species. Scavengers follow predators, waiting for leftovers. Symbiotic relationships bloom, between corals and algae, between fish and anemone-like creatures, between creatures that will never leave the water and others that may one day walk on land. Beneath the sandy shallows, burrowing creatures stir. Worms, mollusks, and crustaceans churn the sediment, oxygenating the seabed and creating microhabitats for countless others. Shellfish cling to rocks. Spiny creatures resembling early sea urchins creep slowly along. Ammonoids, relatives of squids and octopuses, drift by, their coiled shells gleaming as they jet through the water with graceful pulses. And yet, for all its beauty, this ocean is not entirely serene. Life here is ruled by competition, by adaptation, by the ceaseless pressure to survive. Each creature's form is a story, of pressures faced, of predators escaped, of food pursued and offspring protected. In these oceans of opportunity, the rules are simple. Those who adapt thrive. Those who do not disappear. Storms sometimes pass overhead, stirring the waters and scattering sediment. Lightning crackles above the waves, and rains hammer the surface. But below, life continues. Reefs may be damaged, only to regrow. Populations may ebb and flow, but always something new emerges to fill the space. You rise toward the surface, watching the changing play of light. The world above remains quiet and sparse, but here below, it is a world of vibrant complexity. Evolution is accelerating. Diversity is multiplying. Every niche, every depth, every current is home to some new form. This is the Devonian Sea, bountiful, ancient, and alive with possibility. And now, among the creatures who glide and glitter through these waters, comes a new innovation. Not just movement or defense, but mastery. The emergence of jaws will forever alter the balance of life in the ocean. In our next chapter, we will meet the jawed fishes, nature's new architects of power, precision, and predation. You glide through the calm of the Devonian Sea, just beneath the surface where sunlight refracts in golden shafts, and the coral gardens below sway with the ebb and flow of the current. Around you, life flourishes in vibrant abundance. But something new is stirring. A quiet revolution is taking place, one that will reshape the marine world forever. And it begins with a bite. Until now, the seas have been ruled largely by jawless creatures, agnathans, who scrape and suck their food from surfaces, using soft mouths and passive feeding strategies. But here, in this precise moment in Earth's history, a new kind of fish is beginning to rise. The jawed vertebrates, or gnathostomes. You hover beside one now, a sleek creature perhaps a meter long. Its body is covered in a mosaic of armored scales, and at the front of its face a pair of firm, hinged jaws snap open and shut. Inside you glimpse rows of primitive, bony teeth, not the enamel-tipped razors of modern sharks, but something more basic, yet still powerful. This is a predator. It no longer waits for food to drift by, it hunts. The evolution of jaws is a monumental leap in biology. At first glance, it may seem like a simple change, bones that pivot, muscles that pull. But in truth, jaws are a master key, unlocking whole new ways of living. With jaws, fish can grasp, crush, slice, and chew. They can eat prey larger than themselves. They can defend against attackers. They can manipulate their environment. From this point forward, life will never be the same. You watch as this early-jawed fish, a placoderm, drifts into a school of smaller, softer fish. With a quick motion, it strikes, jaws clamping down with sudden force. The prey disappears in a cloud of bubbles and scales. Nearby, others follow suit, chasing and biting, engaging in a dance of speed, sight, and precision. The age of passive feeding is giving way to the age of active predation. Placoderms are among the first of the jawed fish to dominate the seas. Their name means plate-skinned, and it suits them well. Their heads and chests are encased in heavy, bony armor, like natural helmets. Their bodies, in contrast, are more flexible, allowing for surprising agility. Some are small and quick, skimming across reef edges in pursuit of prey. Others, like the colossal Dunkleosteus, are true giants, up to 10 meters long, with crushing jaws strong enough to bite through bone and shell alike. You drift beside one of these titans. Its head alone is the size of a human torso, and its eyes, enormous forward-facing, watch the world with both focus and intelligence. Its jaws open wide, revealing not teeth but sharp-edged bony plates that scissor shut with terrifying power. It swims with the slow confidence of an apex predator, unchallenged and serene. But placoderms are not the only jawed fish making waves. A different kind of swimmer darts past you, lean, torpedo-shaped, with a flexible skeleton made of cartilage instead of bone. These are the early chondrichthyans, the ancestors of sharks and rays. Without heavy armor, they rely on speed and sensitivity. Their skin is tough and sandpaper-like, covered in tiny denticles. Their senses are acute. They can detect movement, electrical fields, even the faintest hint of blood in the water. One circles around you now, its silhouette casting a shadow on the seafloor below. It is smaller than the placoderm, but no less deadly. Jaws lined with rows of sharp, replaceable teeth flash in the light. With a flick of its tail, it vanishes into the blue. And yet another group is beginning to rise, bony fishes, or osteichthyans. These include two major lineages, the ray-finned fish, whose fins are supported by long, thin bones like fan spokes, and the lobe-finned fish, whose thicker, fleshy fins contain internal bones and muscles. The latter, as you'll see, will one day step onto land. The ray-finned fish are already displaying remarkable adaptations. Their scales overlap like armor but remain lightweight. They move with grace and speed, able to maneuver through tight spaces in the reefs. Some feed on plankton, others hunt insects near the surface. Their jaws are more refined, hinged in multiple places, allowing for powerful bites and even suction feeding. The rise of jaws is not only a story of hunting, it is also a story of sensing, of seeing, of reacting. With jaws comes the need for better eyes, stronger muscles, faster reflexes. Brains grow more complex. Nervous systems become faster. You are witnessing the rise not just of new bodies, but of new behaviors, strategy, awareness, choice. You watch as one lobe-finned fish, perhaps a eusthenopteron, slowly fans its thick fins along the muddy sea floor. It is not chasing prey but rather seeking shelter, nosing between rocks, exploring. The bones in its fins are homologous to those that will, millions of years later, form the arms and legs of terrestrial animals. Already, evolution is pointing toward the land. This explosion of jawed fish brings with it competition, specialization, and innovation. Some become ambush predators, lurking in the shadows. Others evolve schooling behavior, finding safety in numbers. Some develop camouflage, blending into coral or sand. Others flash bold patterns to confuse or warn. The Devonian Sea is no longer just diverse. It is dynamic. You drift now through a forest of life, and you see not just variety, but purpose. Every shape has a reason. Every fin, every scale, every tooth tells a story of survival, and it is far from over. As we move deeper into the age of fishes, the sea will bring forth even more remarkable forms. Colossal hunters, agile flyers of the current, and eventually, the ancestors of creatures who will leave the water behind. But first, let us meet the armored giants who claim the title of Earth's first true kings of the sea. The ocean deepens around you. Its colors darken, from turquoise to blue-gray, as you descend into a wide open basin. The coral reefs fall away, and you now enter a quieter part of the Devonian world. Here, the water is cooler, more open and still. But you are not alone. A shadow moves just beneath you, then another. The silence is deceptive. Before you, an enormous shape emerges from the gloom. Its silhouette glides forward, broad, muscular, and covered in a lattice of thick interlocking plates. This is a Dunkleosteus, perhaps the most fearsome predator of the Devonian seas. It is one of the largest placoderms to ever exist, and in this age of fishes, it reigns as a true giant of its time. You hover at a safe distance, watching it pass. Its head and thorax are clad in massive, bony armor, like a knight in ancient metal plating. Its tail and rear body, by contrast, are more streamlined, allowing it to thrust forward with surprising bursts of speed. Its jaws, formed not by traditional teeth but by sharpened bone plates, can open and close with such force that they can shear through the armor of other placoderms in a single bite. This is not just a fish. It is a calculated engine of predation, and it is not alone. Throughout the mid to late Devonian seas, placoderms dominate the food web. Their armored forms are diverse. Some are small and flattened, designed for life close to the seabed, where they sift through sediment for crustaceans and worms. Others, like Bothrialepis, are bottom dwellers with wing-like pectoral fins and a curious head shape, adapted for suction feeding in silty shallows. Their movements are gentle and methodical, stirring up clouds of sand as they explore. Many of these creatures bear armor that is not just protective, but beautiful. Elaborate patterns etched into their bony plates, textures that catch the light, and grooves that reveal the evolutionary experimentation of the time. It's as if nature, newly equipped with the jaw and the vertebrate form, is sculpting an entire orchestra of biological possibility. Some placoderms are relatively passive, grazing on soft-bodied prey or algae, while others are ambush hunters, remaining motionless until a shadow crosses overhead. Then, in a blur, they strike, jaws opening wide, gill plates flaring, water rushing in behind their prey. One fascinating feature of placoderms is their internal skeleton. Unlike the more primitive cartilaginous fish, their skulls and vertebrae are made of true bone, offering greater support and attachment for powerful jaw muscles. They also show early evidence of live birth. Fossil records have revealed placoderm embryos preserved inside the bodies of females, an astonishing level of reproductive advancement for such ancient creatures. You imagine the waters filled with these armored beasts, each species occupying its own niche. Some patrol the reef edges. Others explore muddy lagoons. Some rest in the shallows, half buried in sand. They are not fast like sharks, but they are powerful, deliberate, and immensely successful. But the Devonian Sea is no peaceful kingdom. Competition is fierce. Predators challenge predators. Smaller species avoid open water, knowing that any flick of movement might be their last. A juvenile placoderm skims through the silt, only to be snatched in a blur by a faster hunter lurking in the shadows. Farther offshore, other ancient hunters take to the open water. Early sharks, sleeker and more flexible, share this space with the placoderms. Though smaller and less heavily armored, they are faster, more maneuverable, and perfectly tuned for pursuit. Some are covered in shimmering, tooth-like dermal denticles, which reduce drag and allow them to slice through the water like a blade. These sharks, unlike the more aggressive modern forms we know today, are diverse and experimental. Some have flat heads and long ribbon-like tails. Others are short and barrel-bodied. Still others resemble rays or chimeras. Their jaws, made of cartilage, house replaceable rows of sharp teeth, and their senses are highly developed, able to detect prey through vibration, smell, and electric signals. As the placoderms rule the reefs and inland seas, these early sharks are claiming the outer edges, open water, deep basins, and the darkened pelagic zones where quick strikes and swift escapes define life and death. But the arms race is not limited to strength and speed. New forms of defense evolve, too. Some fish develop spines, barbs, and thick scales. Others use mimicry, camouflaging themselves among coral, rocks, or even within schools of similarly shaped species. Some develop long, ribbon-like bodies to slip unnoticed through crevices and caves. You drift now through a rocky trench where light grows dim and the terrain is jagged. Here, ancient lobe-fins patrol, their powerful limbs helping them maneuver among outcrops. A sudden burst of motion reveals a predatory placoderm, half buried, lunging forward to snap at a passing swimmer. Dust and bubbles fill the water in its wake, and yet, not all is violence. Many armored fishes move with grace. You observe a group of smaller placoderms swimming in formation, perhaps migrating, their plated forms catching glints of light as they rise and fall in the current. Their heavy armor slows them, but they move with a kind of rhythm, an ancient choreography written in instinct and adaptation. For tens of millions of years, these armored giants dominate the seas. But they are not eternal. As new species emerge, ecosystems shift, and subtle pressures begin to mount. The age of the placoderms will eventually wane. But for now, in this Devonian world, they are kings and queens of the deep. And as we move forward in time, we'll follow another lineage, leaner, faster, and far less armored. In the next chapter, we'll swim with the rising lineage of sharks, streamlined hunters who will ride the evolutionary currents far into the future. You drift now toward the edge of an ancient reef, where the soft curves of coral give way to deeper, open waters. The world here is quieter, less crowded with the bustling life of the shallow reef, but no less alive. In this transitional zone between reef and ocean, a new kind of predator begins to appear. Sleek, agile, and honed by evolution to perfection. These are the sharks of the Devonian. The word shark might conjure images of modern giants with rows of serrated teeth and cold, calculating stares. But in the Devonian, these creatures are still in their early forms, ancient prototypes that will one day give rise to the diverse, powerful lineage that survives even into your time. You see one now. It glides through the water in a slow, graceful arc. Its body long and lean, with a powerful tail and a snout that slices the current like a blade. Its skin glistens like rough silk, covered in dermal denticles, tiny tooth-like scales that reduce drag and shimmer faintly in the filtered sunlight. It has no bones, only cartilage, strong, flexible, and light, giving it incredible mobility and a weightless, almost effortless motion. Unlike the heavily armored placoderms, early sharks do not rely on brute force or thick plates. Instead, they are specialists in motion, speed, and sensory awareness. Their bodies are built for stealth and precision, not defense. And in this way, they open up new evolutionary possibilities in how life can hunt, flee, and survive. You follow as it swims in a wide loop, and then you see another smaller shark following close behind. This one's body is flatter, with broad, wing-like pectoral fins. It hovers closer to the seafloor, stirring up sand as it searches for invertebrates buried beneath. Others flash by above you, slender shadows that flicker past in sudden bursts, disappearing just as quickly as they appeared. The sharks of this era are varied and experimental. Some, like Cladosalachi, are around 2 meters long with broad fins and strong jaws filled with sharp, multi-cusped teeth. Their eyes are large and forward-facing, and their bodies are unarmored, relying on speed and agility to chase down prey. They hunt in short bursts, often working in pairs or groups to corner smaller fish. Fossils suggest they were fast swimmers, capable of sudden acceleration and sharp turns. You notice how they swim, not with the full-body undulations of eels or jawless fish, but with a rhythmic flex of the tail, slicing side to side. Their fins stabilize them, giving them control in all directions. They maneuver through narrow passages in the reef, weave between coral outcroppings, and pursue prey into open water with astonishing finesse. As you observe their hunting strategies, you begin to see something remarkable. Sharks are more than just predators, they are innovators. Their keen senses include electroreception, the ability to detect the faint electrical fields generated by other animals. They also have a powerful sense of smell, able to detect a drop of blood in vast volumes of water. Their lateral lines sense vibration and movement, alerting them to disturbances long before a visual cue appears. You witness one shark glide silently along the reef wall. Its eyes scan the gloom. Then, with no warning, it veers sharply, descending into a cloud of sediment. A moment later, it emerges with a wriggling prey in its jaws. There was no sound, no signal, but it knew. It felt the life below before it ever saw it. Other species show even stranger forms. Some have elongated, paddle-like snouts used for sweeping sediment. Others have long dorsal fins, or even fin spines that serve as defense against larger predators. One has broad, ribbon-like fins that flap gently as it hovers in the shallows, an ancestor of the rays that will someday grace tropical lagoons. Their eggs are often encased in tough, leathery shells, spiral-shaped or horned, and left in safe places on the sea floor. Some may even carry their young for a time before releasing them. The fossil record hints at reproductive complexity and flexibility in strategy, signs of a lineage well adapted to survive and adapt. And yet, for all their power and grace, the sharks of the Devonian are not invincible. They share the seas with the massive placoderms whose armored jaws can crush even agile prey. In some regions, sharks are outnumbered, confined to particular niches where their speed and senses give them an edge. But they endure, and that, perhaps, is their greatest strength. Over the next tens of millions of years, sharks will continue to evolve. They will survive extinctions, climate changes, and the rise and fall of countless other species. Their forms will change, diversify, and specialize. But their essence, their speed, sensitivity, and silent elegance will remain. You surface now from the open waters, letting the warm currents carry you gently back toward the reefs. Behind you, the shadows of sharks fade into the blue. They are ancient, yes, but they are also timeless. Their reign has only just begun. In the next part of our journey, we'll turn from these sleek hunters to another great evolutionary fork in the Devonian Sea, the bony fish. From them will rise not only countless aquatic forms, but eventually the first creatures to walk the land. You ease your way back into the warm, sunlit shallows of the Devonian seas. The light here is dazzling, playing across the rippling sand like liquid fire. Coral outcrops stretch in all directions, and between their crags a new group of fish moves with elegance and efficiency. You are witnessing the rise of the bony fish, creatures whose internal skeletons of true bone allow for an entirely new kind of control, mobility, and diversity. This is a quiet revolution. These fish are the ancestors of almost all vertebrates alive today, from trout and tuna to birds, reptiles, and even you. But here they are still primitive, exploring the early paths that evolution lays before them. Their jaws are more refined. Their gills are protected by bony plates called opercula, and their scales, ganoid or cycloid, gleam in the filtered sunlight like coins scattered across the seafloor. You watch as a school of ray-finned fish, actinopterygians, drifts past in a coordinated wave. Their name comes from the long, slender bones that fan out through their fins like spokes in a delicate umbrella. This structure gives them fine-tuned control over their movements. They can stop, hover, pivot, or dart in an instant. With every flick of their tails, they demonstrate the kind of agility that makes them such successful swimmers. Their bodies are built for the open sea, light, quick, and energy efficient. They dominate the water column, from sunlit surface zones to dim reef crevices. Some graze on algae growing along the reef. Others feed on zooplankton. Still others are predators in their own right, darting into tight clusters of smaller fish, jaws snapping, scales flashing in the frenzy. And yet, as you float deeper toward a rocky outcrop, you spot another form, one less graceful, more deliberate, and perhaps even more important. A thick-bodied fish, moving slowly, hugging the rocks and resting often on the sea floor. It is a lobe-finned fish, a sarcopterygian. At first glance, it seems similar to its ray-fin cousins. It has scales, gills, and jaws. But then you notice its fins. They are not thin fans of rays, but muscular lobes, each supported by a robust series of bones. And these bones, if you look closely, resemble something familiar. The bones of a limb, a humerus, a radius, an ulna. Precursors of arms, legs, wrists, and fingers. You've met a distant relative. This fish, perhaps Eusthenopteran or Panderichthys, is part of a lineage that will give rise eventually to amphibians, reptiles, mammals, and humans. But for now, it remains firmly aquatic, its powerful fins helping it to navigate dense underwater vegetation, prop itself against currents, or wedge into crevices where prey may be hiding. The lobe-finned fish are slower and less maneuverable than ray-finned fish, but they are strong, adaptable, and highly versatile. Some evolve lungs, real, functioning lungs, that allow them to gulp air from the surface when oxygen levels fall in stagnant water. Others develop spiracles, small openings atop their heads that aid in breathing, especially when resting close to the bottom. In quiet lagoons and oxygen-poor swamps, these adaptations become crucial.
De préparer pour faire des précipitous pour t'en mettre là.
When others suffocate, the lobe fins endure. They can breathe, they can push, they can rest in the shallowest, most suffocating waters and survive. You watch one as it rises slowly through the water, gulps air with a flick of its gill cover, and settles again among the reeds. It is not graceful, but it is enduring. Another curious member of this lineage swims by, a coelacanth, with strange lobed fins that seem to rotate like limbs. It glides through the water with a slow, undulating motion, eyes alert, jaws snapping now and then at passing prey. These coelacanths will one day disappear from the fossil record, thought extinct for 66 million years. Until one is caught alive in 1938, proving that the Devonian still echoes in modern oceans. Then there are the lungfish, odd creatures with flat bodies, powerful lungs, and stubby fins. They burrow into mud during dry seasons, forming mucus cocoons and entering a state of torpor. They too survive where others perish, their lineage eventually spreading to Africa, South America, and Australia. They will persist for hundreds of millions of years, reminders of a time when water and air were not yet separate domains. You float silently, observing this crossroads of evolution. The ray-finned fish are specialists, fast, sleek, and diverse. They will come to dominate Earth's oceans and freshwater systems for the rest of time. Today, they make up over 95% of all known fish species. But it is the lobe-finned fish, slower, rarer, more awkward, who will shape the next act of Earth's story. Because their fins can become limbs, their swim bladders can become lungs, and their bodies can adapt to the strange, heavy world above the water surface. For now, the land remains quiet, save for plants and the occasional arthropod. But the lobe fins are coming, and in the next chapter, we'll rise from the sea with them, crawling slowly onto the muddy banks of lakes and rivers, where, for the first time, vertebrate life will feel the warmth of the sun not just on its back, but on its skin. The sea behind you recedes into a gentle hush, its waves breaking softly against a shoreline not yet shaped by time. You step ashore, tentatively, slowly, onto a muddy bank that glistens in the afternoon light. This is not a land of towering forests or verdant meadows. It is raw, primitive, and almost alien. The air is thick, humid, and warm. The sky above hangs low, tinged with bronze, as sunlight filters through an atmosphere still adjusting to the quiet work of photosynthesis. This is Devonian Earth, and life is beginning to crawl from the water. You kneel by a shallow stream that trickles through smooth stones and soft clay. Along its edge, clusters of mosses and liverworts form the first thin carpet of green. They are small, just a few centimeters tall, without roots or flowers, yet they are alive and thriving. Their spore capsules sway on slender stalks, waiting for the wind or the touch of an insect to spread their genetic legacy to new patches of damp ground. Nearby, the soil is broken by something taller, primitive vascular plants like Cooksonia, with hollow stems and spore-filled tips. They stand just a hand's height, branching simply and swaying in the breeze. These plants mark the beginning of internal fluid transport, a quiet evolutionary leap that will allow future plants to grow tall, strong, and complex. They anchor the land, holding moisture and shaping the first true ecosystems of the terrestrial world. But this world is still dominated by silence. No birds sing, no mammals stir. The only sounds are the occasional rustling of wind-blown spores, the lap of water, and the crackle of dry stems underfoot. It is a place waiting to be filled. And slowly, it is. You lean closer to a shaded pool of water left behind by the tide. There, nestled among pebbles and decaying plants, something stirs, a soft movement, a glint of an eye. Then, the flick of a tail. It is an arthropod, perhaps a eurypterid or sea scorpion, one of the earliest animals to test the land. It scuttles forward with caution, its segmented limbs gripping the damp earth. These creatures evolved in water, but now some venture onto land in search of food, warmth, or shelter. Their hard exoskeletons protect them from drying out, and their bodies are suited to crawling as well as swimming. You follow one as it makes its way over a mossy rise, antennae twitching, sensing a new world. Others join it, millipede-like creatures, early spiders, and tiny springtails, all forming the vanguard of invertebrate colonization. But something else is coming. Something with bones, muscles, and lungs. At the edge of a still pond, you wait. The surface ripples gently. Then, from beneath the muddy water, a shadow rises. A flat head emerges, eyes atop like twin domes. Then broad, muscular fins press down into the muck, lifting the body ever so slightly. This is a tetrapodomorph, perhaps Tiktaalik or one of its kin. It is not yet a land dweller, but it is no longer fully aquatic. Its fins are strong, with jointed bones that mimic shoulders, elbows, and wrists. Its ribs are robust, able to support the weight of its body, at least for brief moments, on solid ground. And most importantly, it can breathe air. You watch as it lingers at the water's edge, nostrils flaring, eyes alert. It lifts its body slightly, lunges forward, and then settles again. It is awkward and slow, but it is here, on land. One breath at a time, one step at a time. These are the first vertebrates to explore life beyond the waterline. They are not yet amphibians, but they are getting closer. They do not run or leap, but they can drag themselves through mud from one pool to the next. In an age where droughts can trap fish in shrinking puddles, such mobility is an advantage that could mean survival. You observe as the animal retreats into a shallow pool, leaving behind a faint trail in the mud. It is joined by others, some smaller, some more fish-like. They explore, rest, and return to the water in rhythms shaped by instinct and chance. Evolution is not always a leap. It is often a slow, uncertain crawl. Above them, the land is transforming. The plants grow taller, spores spread farther, insects begin to flutter on early wings, fungi spread through the soil in vast underground webs. The air, once thin and harsh, begins to carry more oxygen, filtered and created by the growing plant life. You wander farther from the shoreline. The ground rises slightly, and the plant life grows denser. Simple trees, club mosses and horsetails, emerge in the wetter regions, their stems lined with spiraling leaves. They lack flowers or fruits, but their towering forms cast the first shadows across the land. And where this moment, quiet, muddy, and filled with trial and error, marks the beginning of a monumental change in Earth's story. Life has not fully conquered the land, but it has placed its first flags here. And with every generation, it will grow bolder, more capable, and more diverse. From these early experiments will come salamanders, frogs, and reptiles. Then, in time, mammals and birds, but it all begins with these soft steps in the Devonian mud, where gills meet lungs, fins meet feet, and water meets sky. In the next section, we will step into the shade of Earth's first forests, tall, green, and filled with promise. A canopy rises, and with it the stage expands for life to take root, spread, and reach for the sun. You walk slowly now, away from the shoreline where the sea's voice fades behind you like a distant memory. The ground beneath your feet grows firmer, drier, and more textured, no longer soft mud, but something new, early soil, forming quietly beneath your steps. The Devonian sun casts a hazy glow overhead, filtered through a veil of moisture and primitive atmosphere. Around you, the land begins to change, not with sudden drama, but with a subtle, persistent upward reach. You are stepping into Earth's first forests. At first glance, they don't look like forests you'd recognize. There are no leaves rustling, no birdsong echoing through the canopy, no mammals hiding in underbrush. But the silence is misleading. These forests are alive, and they are revolutionizing the world. The plants here are larger than the mosses and creeping stems of earlier ages. Towering club mosses rise several meters high, lycopods with straight trunks and spiraling leaves. Some of them, like lepidodendron, will eventually reach heights of over 30 meters. Their bark is patterned like scales, and they grow in thick stands along riverbanks and floodplains. Beside them, horsetails, giants compared to their modern descendants, stand like segmented pillars, jointed and hollow. Their leaves form whorls around each stem, and their cones produce spores instead of seeds. They gather moisture and sunlight, thriving in the damp ground, pushing skyward. You run your fingers along a trunk, not woody in the way modern trees are, but strong and ridged. It supports itself with internal pressures and a columnar structure. This is Archaeopteris, one of the first true trees. Its roots dive deep, its branches spread wide, and its leaves, fern-like and lacy, catch the sunlight in soft, green patterns. Unlike earlier plants, Archaeopteris possesses wood, true wood, a vascular system that carries water and nutrients and gives it the strength to grow tall and last long. This tree is a turning point, not just a plant, but an engineer of ecosystems. With trees comes shade, and with shade comes diversity. Small plants gather beneath their branches, shielded from the harsh sun. Moisture lingers in the soil. Microclimates begin to form. Damp hollows, cool groves, sunlit clearings. Ferns, liverworts, and tiny seedless plants spread across the forest floor. Fungi, hidden from view, thread through the soil and decaying matter, breaking down the fallen wood and recycling nutrients. And below all of it, the soil. True soil is forming for the first time in Earth's history. Roots reach downward, fracturing rock and anchoring the land. As roots grow, die, and decay, they create space for air and water. Microbes thrive in this hidden world, breaking down organic material. Layer by layer, this once barren land is being transformed into a living, breathing substrate, one that can support ever more complex forms of life. You stoop to examine the ground beneath a cluster of ferns. A thin layer of dark brown earth clings to the stones. It is moist, rich, and full of fragments. Broken stems, decomposing bark, fungal threads. This is not just dirt. It is Earth's first skin. The air here is different too. Plants release oxygen as they photosynthesize, and over time, the concentration builds. The atmosphere thickens with the breath of forests. The sky brightens, the climate stabilizes. With more oxygen, animal life becomes more feasible on land. The fire of metabolism, breathing, moving, growing, has more fuel. You take in the scents. a mix of damp wood, fresh spores, and cool, shaded air. There is no hum of insects yet, no rustle of mammals or birds, but something else stirs. A eurypterid, an ancient sea scorpion, scuttles from a stream into a thicket of ferns. Nearby, a millipede inches along a root. Early insects, wingless and clumsy, creep up stalks. Life is not just arriving on land. It is beginning to organize, to adapt, to diversify. And the forests play a crucial role in this. They stabilize the land against erosion. They regulate water through their roots and shade. Their fallen leaves and branches become habitat and food. They influence weather and carve channels for rivers and streams. Even death here is different. When a tree dies, it leaves behind more than decay. It leaves structure, shelter, and nutrients. Some of these trees fall and become buried in sediment. Over time, their carbon-rich bodies will form coal beds that store the energy of ancient sunlight, locked away until future creatures unearth them. You walk deeper into the forest, stepping over roots, brushing past ferns as tall as a person. Light filters through the green canopy in soft beams. There is no sound of human presence, no voices, no footsteps. Only the gentle swish of spores falling like dust motes and the distant splash of a small stream. In this silence, the world is changing. The forests of the Devonian are not just biological marvels, they are planetary ones. They alter the chemistry of the atmosphere, they shape landscapes. They lay the groundwork for everything that comes next. And soon, among their roots and along their shaded paths, creatures with limbs and lungs will begin to linger longer and explore farther. No longer just visiting land from the water, they will begin to call it home. In our next chapter, we'll meet the pioneers of that transition, air breathers and limb bearers, whose every cautious step on land will ripple forward through time, all the way to us. You sit quietly now at the edge of a shallow Devonian pond, its surface dappled with late afternoon light, filtered through the overhanging branches of Archaeopteris. The water is still and clear, disturbed only by the occasional ripple of something moving just beneath. Around you, the forest hums in its quiet, steady way, wind brushing against tall fronds, spores drifting on the air, and the soft trickle of a stream feeding the pool. Then, from the far bank, a strange shape shifts. A flat, wide head rises just above the surface. Two eyes, set atop like twin domes, blink slowly. A body follows, broad, muscular, and sinuous. It moves not with the smooth glide of a fish, but with effortful thrusts, its fins pushing awkwardly against mud and submerged roots. You are watching a moment unlike any other. The hesitant emergence of vertebrate life onto land. This is a tetrapodomorph, one of a group of lobe-finned fish that now walks a line between water and air, past and future. Its name might be Tiktaalik or Acanthostega or Ichthyostega, early experiments in movement, respiration, and structure. These animals are not yet fully land dwellers, but they are no longer just fish. They are something in between. Its broad fins press into the soft earth beneath the water, and you see what evolution is crafting. A shoulder joint, an elbow, a wrist. The bones mirror your own, though still adapted for pushing rather than walking. With each press, the creature lifts part of its weight, gaining leverage, balance, and control. These are the earliest limbs, fleshy fins becoming feet. But it is not just about movement. This animal lifts its head, opens its mouth, and draws in air. Lungs, simple sac-like organs, inflate within its body. Many of its ancestors already had these lungs as backup systems for oxygen-poor waters. But now, on land, they become primary tools for survival. Gills are still present, still useful in water, but they will soon fade for those who stay longer above the surface. You observe as it pauses, its belly half resting on wet ground. It scans its surroundings, alert and cautious. The world above water is rich in new challenges, gravity, dryness, exposure, but it also holds promises, Oxygen in abundance, no aquatic predators, and vast open territory unclaimed by vertebrates. It inches forward, dragging its body over a carpet of damp moss and into a shallow, sun-warmed puddle. Then it rests again. Each journey from water to land is short, tentative, and exhausting. But over generations, these creatures will improve. Their lungs will grow more efficient, their limbs more robust, their skin thicker to prevent desiccation. Their senses, sight, hearing, smell, will adapt to a world once hidden behind the shimmer of water. You hear a faint rustle. Another tetrapodomorph appears. This one is larger, with stubbier limbs and a more muscular tail. It heaves itself up a small incline, rests under a fern, then begins to forage in the wet leaves. Its mouth opens slightly, catching small arthropods unaware. Its eyes are alert, its ribs strong. It is breathing easily now, unbothered by the air. These animals mark the beginning of a new kind of movement, no longer confined to the horizontal plane of swimming, but now exploring the vertical pull of gravity. For the first time, vertebrates are pressing upward, lifting themselves off the earth, standing, however briefly, on 4 limbs. Behind them, their aquatic cousins continue to thrive. Coelacanths, lungfish, and lobe-finns still swim through reeds and channels, unchanged for millions of years. But the tetrapodomorphs are branching off. Evolution is writing a new chapter, one of adaptation, flexibility, and transformation. The forests around them grow thicker. Soils deepen. Insects buzz softly in the undergrowth, and primitive fungi spread along rotting logs. The air is more oxygen-rich now, and this too favors those who breathe it. Creatures with lungs and limbs become bolder, venturing farther from the safety of water. You follow one such creature as it wanders through leaf litter and moss. Its tail drags behind. Its fins press forward. It is clumsy, yes, but it moves with purpose. It is learning the language of land. Fossils of these animals show transitional forms, some with more digits than modern tetrapods, others with internal gills and lungs side by side. Evolution does not erase the past, it builds upon it. Each bone, each organ, tells a story of compromise and experimentation. You imagine their world as a mosaic: ponds, marshes, stream beds, and fallen logs, each a stepping stone for life, testing the boundaries of the possible. The water is always nearby, but no longer the only home. With time, the limbs grow stronger. The neck appears, allowing independent head movement. The ribs widen to support organs, muscles strengthen. And eventually, descendants of these creatures will not return to the water. They will remain on land, exploring, hunting, mating, and nesting entirely above the surface. This transition from water to land is one of the most profound in Earth's history. It is the beginning of terrestrial vertebrate life. Amphibians, reptiles, birds, mammals, all will trace their ancestry back to these muddy footsteps and gasping breaths. And you were here to witness it. You stand now among ferns and tall club mosses, watching as the small pioneers disappear into the underbrush. The pond behind you is quiet once again, but the forest feels changed. The silence is no longer empty. It hums with anticipation. Next, we'll dive once more beneath the waves, not into the open ocean, but into the intricate world of Devonian coral reefs, which have grown into bustling underwater cities. There, life swarms in color and motion, and the age of fishes reaches one of its most dazzling heights. You dive once more into the Devonian Sea, not into the wide open basins where armored giants roam, nor the dim depths where early sharks patrol, but into something more intricate, more intimate, a reef. Not a solitary outcrop or a scattered patch of coral, but a vast, living city beneath the waves. This is the reef of the Devonian, a cathedral of stone, light, and life. As you drift closer, the shapes emerge. Bulbous mounds, finger-like spires, honeycombed structures packed tightly together like buildings in a bustling town. But these are not made by the same stony corals that dominate modern reefs. Here, the architects are stromatoporoids, and tabulate corals. Ancient reef builders that layer calcium carbonate over generations, forming domes and ridges that stretch for kilometers. The water is crystal clear, filtered by currents and held still by the protection of the reef walls. Sunlight beams through in soft golden shafts, revealing a kaleidoscope of color and movement. You glide gently along a coral ridge, and all around you, life unfolds in a constant, coordinated hum. Tiny trilobites crawl across surfaces, picking at bits of algae and detritus. Crinoids wave their feathery arms in the current, catching particles of food. Brachiopods lie open like delicate shells, filtering plankton from the passing water. Nautiloids with elegant coiled shells pulse through narrow channels between coral towers, their tentacles curling and uncurling with purpose. You pause to observe a coral cavity, and within it, dozens of tiny fish dart in and out, their scales shimmering like flecks of bronze and pearl. These are early bony fish, ray-finned and lobe-finned species that have found refuge in the shadows and crevices of the reef. Some are herbivores, nibbling at algae-covered stone. Others are ambush predators, lurking in stillness, waiting for a stray crustacean to wander too close. In every crack, every overhang, every pool of light, life finds a niche. Some fish are flat and wide, pressed close to the sand. Others are slender and quick, flashing from rock to rock. Even the smallest spaces are occupied by worms, shrimp-like arthropods, or early echinoderms that cling with tiny tube feet to the vertical reef walls. Above you, a school of jawed fish sweeps past in coordinated rhythm, each member responding instinctively to the movements of the others. Their bodies twist and arc as one, forming a ribbon of motion that shifts shape like a single living entity. Their presence stirs the water, causing soft fronds to sway and polyps to retract. The reef is not just a habitat. It is an engine of biodiversity. Its complexity creates layers of life, from the base of coral skeletons, where detritivores clean, to the outer ridges where predators lurk, to the open canopy where plankton bloom. It offers food, shelter, mating grounds, and nurseries. It is a place where evolution accelerates, where adaptations are tested daily in a living laboratory of survival and opportunity. You hover near a cluster of tabulate coral, their tightly packed cells forming a honeycomb pattern. Here, a tiny lobe-finned fish wedges itself between the polyps, hiding from a larger predator circling above. The predator, perhaps a small placoderm, glides away after a moment, jaws parting briefly before closing again in frustration. Elsewhere, you see evidence of symbiosis. Algae live within the tissues of some corals, exchanging nutrients and oxygen. Crustaceans tend to coral gardens, eating away dead matter and debris. Worms burrow through sponge bodies, creating microhabitats in their wake. You notice a young reef beginning to form nearby. Tiny coral larvae settle on clean stone, begin to grow, and attract new residents. Over decades and centuries, this patch will grow, layer upon layer of skeleton and life, until it becomes another pillar in the ever-expanding reef complex. But these cities are not eternal. Storms occasionally rage above, stirring the seas and toppling coral spires. Shifts in sea level drown some reefs while exposing others. Periods of low oxygen in the water, anoxia, cause temporary die-offs, leaving patches of bleached, barren rock. But the reef recovers. Slowly, methodically, life returns, regrows, rebuilds. And yet you sense something distant on the horizon. A slow, subtle tension in the ecosystem. As species multiply and compete, as climates shift and oxygen levels fluctuate, the balance becomes more fragile. This dazzling reef, for all its strength and beauty, may one day falter. But for now, it thrives. You float to the top of the reef, where the water is warmest and the light strongest. Here the reef bursts into full display. Crinoids, corals, fish, and invertebrates, all moving in concert, a choreography of life in perpetual motion. Schools flash silver, coral polyps pulse softly. Tube worms extend their crowns, capturing plankton as it drifts by. It is easy to lose yourself here. The stillness, the color, the complexity. Every surface is alive. Every shadow holds a story. Every crevice echoes with ancient movement. You imagine this reef as a city without maps, where no corner is known entirely, yet all of it is inhabited. The Devonian reefs are the most extensive in Earth's history. They stretch across continents, create new coastlines, and shelter an explosion of forms. They are the hearts of the ocean, beating, breathing, building. But even these great cities are not immune to change. In the next part of our journey, we will begin to feel the first tremors of that change. The oceans will darken. Oxygen will decline. Reefs will fall silent. And life will face its first major crisis since the Cambrian, a slow, suffocating extinction that tests the resilience of even the strongest. You awaken to a shift, not sudden, but undeniable. The waters are different now. Where once they sparkled clear and full of motion, a faint haze lingers beneath the surface. The coral reefs you visited earlier appear muted. Colors are less vivid, movements slower. Something is changing, and the sea, always a patient mirror of Earth's deeper rhythms, is beginning to whisper of trouble ahead. You descend gently into the mid-Devonian Ocean, and the first signs meet your senses as subtle absences. Fewer fish dart among the reefs. The water, though warm, seems heavier, its oxygen content lower. Crinoids sway more languidly, and trilobites cluster tightly as if seeking shelter. There is no panic here, no violence, just a creeping silence that grows stronger each day. This is the beginning of a quiet crisis. A long and complex unraveling, known to paleontologists as the Late Devonian Extinction. But it does not strike like lightning. Instead, it creeps in like fog, settling into every corner of the ocean with aching slowness. You float through a shallower basin now, one that was once teeming with life. The seafloor is soft, siltier than before. Where reef-building corals once stood tall, broken fragments lie scattered, still beautiful, but lifeless. A once colorful reef now appears like an abandoned city, its towers collapsed, its streets empty. So, what happened? The answer lies in a combination of forces, each overlapping, each compounding the next. Earth, at this moment in the Devonian, is undergoing climatic shifts. The once stable warmth of the early and middle Devonian is interrupted by fluctuations in temperature, cooling periods that alter ocean currents, disrupt ecosystems, and affect where and how species can thrive. You drift upward, into waters touched by runoff from the land. The forests you once walked through, the first true forests with deep roots and towering trunks, are not without consequence. Their growth fundamentally alters the Earth's systems. Roots break down rock, accelerating weathering. Rainwater, now rich in nutrients and organic material from decomposing plants, flows into rivers and eventually into the sea. And this too changes everything. Nutrient-rich runoff feeds plankton blooms, but as these blooms die and decompose, they deplete oxygen in the water. In shallow seas, oxygen is replenished by wind and waves. But in deeper basins, where circulation is limited, the decay of organic material consumes the available oxygen and leaves the water depleted, hypoxic. Eventually, in some regions, the water becomes entirely anoxic, devoid of oxygen. You enter one of these basins now. The light dims. The water is still. There is no movement here. No fish, no invertebrates, no bubbling algae. Only darkness and silence. This is the realm of the anoxic ocean, a growing phenomenon during the late Devonian. The effects ripple outward. Coral reefs begin to collapse. Many reef-building species go extinct. Jawed fishes, once dominant, see sharp declines in diversity. Placoderms, including the great Dunkleosteus, begin to vanish from the fossil record. Trilobites lose entire families. Ammonoids and conodonts suffer massive losses. But the extinction is not a single moment. It is a series of pulses, waves of collapse separated by thousands to millions of years. Each pulse seems tied to a shift, A drop in sea level, a rise in temperature, a drop in ocean oxygen. Some scientists call these pulses the Kälwasser events, named for the dark shale layers in Germany where their traces were first found. You examine a cliffside now, its layers of stone telling the story in darkness and light. Bands of black shale mark anoxic periods. Fossils disappear above each band, whole lineages erased. The deeper layers are filled with life, the higher ones quieter. Earth is leaving a record of disruption, and you can read it in stone. And yet, not all life is lost. Some species retreat into sheltered habitats, lagoons, estuaries, brackish waters, places less affected by anoxia. Others evolve to tolerate low oxygen. The lungfish, with its ability to breathe air, thrives. Some early amphibians crawl further onto land where oxygen is plentiful. Ferns, mosses, and fungi continue their quiet work in the soil. From the devastation, evolution forges new paths. You return now to the coastline, where the sea meets land. The sun sets behind the Devonian horizon, and the light reflects on a surface calmer than before. You sit at the edge, your feet in the shallows, and feel the heaviness in the water. It is not death, but transformation. The Devonian is ending, and with it, one of the most creative periods in Earth's evolutionary history. In the next part of our journey, we'll witness the collapse continue, but also follow those who endure. For every extinction, there is resilience, and some of the survivors of this quiet catastrophe will lay the groundwork for the next great evolutionary leap. You stand at the edge of time again, as the Devonian world begins to dim. The golden age of reefs, the flowering of fish, the creeping of life onto land. All of it now draped in a slow, invisible veil. It is not a single cataclysm, not an explosive event like a meteor impact or volcanic outburst. Instead, the Devonian closes with a soft but persistent exhale, a long, suffocating decline. This is the late Devonian extinction, one of Earth's 5 great mass extinctions. But unlike the others, it unfolds not over days or centuries, but millions of years. It is a drawn-out unraveling, a series of interruptions that cascade through ecosystems, each more subtle and quiet than the last, yet devastating in their collective weight. You return now to the oceans, the birthplace of so much Devonian splendor. The reefs, once vibrant, are skeletal. The bustling reef cities have faded, their tabulate corals and stromatoporoids now extinct or dying. For over 100 million years, these reef systems dominated shallow seas across the globe, but now their voices have gone quiet. And they will not recover for tens of millions of years. The sea, once clear and rich with life, feels murky. You drift above the sediment, where broken shells and lifeless crinoid stems lie scattered like forgotten architecture. You pass what remains of a placoderm, its armored plates half buried, its bones disarticulated. These titans, who once ruled the oceans with crushing jaws and thick skulls, vanish during this extinction. No placoderms will survive past the end of the Devonian, and yet the extinction is not uniform. It pulses. 2 major episodes spaced about 10 million years apart. The first, known as the Kälwasser event, is tied to low-oxygen black shale deposits that stretch across what are now Europe, North Africa, and North America. These layers tell of oceans gone still, stripped of circulation, depleted of life-giving oxygen. The second pulse, the Hengenberg event, seals the Devonian's fate. It wipes out many of the survivors from the earlier collapse. By its end, around 75% of marine species are gone. You notice the emptiness. Whole groups have vanished. Trilobites, once common and diverse, are reduced to a handful of forms. Many brachiopods disappear. Ammonoids dwindle. Conodonts, tiny eel-like vertebrates, whose tooth-like fossils trace evolutionary change, show sharp declines. Even the coral-like rugosins, those horn-shaped reef builders, lose much of their diversity. What causes this sustained extinction? The answer, as always in deep time, is layered. Climate change plays its part. The spread of land plants, with their deep roots and weathering effects, alters Earth's carbon cycle. Weathering draws down carbon dioxide from the atmosphere, triggering cooling. As glaciers form and sea levels drop, shallow marine habitats, where most Devonian life resides, vanish. Then, in cycles, warming returns, melting glaciers releasing trapped carbon and destabilizing ecosystems again. Anoxia, oxygen loss in the oceans, continues to expand. Dead zones creep across the seafloor. These conditions, once isolated, become global. Even the open ocean is not immune. Entire ecosystems collapse as food chains falter. Top predators starve. Bottom dwellers suffocate. You observe a ray-finned fish swimming alone through a barren reef shelf. Its body is thin, its fins damaged. It is a survivor, but barely. Nearby, a lobe-finned fish burrows into sediment, hiding in a shallow pool. These two lineages will outlast the extinction, but most of their relatives will not. And yet, this is not the end of life, only a narrowing. On land, the forests endure. Though some plant lineages shrink, others thrive. Lycopods, horsetails, and ferns continue to colonize new regions. The soil grows richer, deeper. Streams and rivers become more complex, carving new paths between groves and grottos. Amid the roots, small creatures stir. Insects buzz on primitive wings. Millipedes wind across the forest floor. And in the shaded marshes, early tetrapods persist. Those cautious breathers and limb-bearers you met before. Some die out. Others find ways to adapt. Their skeletons grow stronger, their lungs more efficient, their legs more reliable. You kneel beside a still pond where an early amphibian, perhaps Ichthyostega, rests half-submerged. Its gaze is steady. Its flanks rise and fall with breath. It listens to the world above water as much as below. This lineage, fragile but determined, will carry the vertebrate story forward. So too will the survivors of the sea. Though coral reefs vanish, some bony fish expand in their absence. Sharks evolve new forms. Ray-finned fish diversify in the open ocean. Lobe-finned fish give rise to lungfish and coelacanths that retreat to deep, quiet refuges. These survivors inherit an emptier world, but one filled with possibility. You reflect on the nature of extinction, not as an end, but as a turning, a reshaping, a reset. The Devonian did not conclude in fire or ash, but in suffocation and silence. And yet out of that silence, new voices will rise. In the next section, we'll meet the survivors more closely. Those who adapted, who persisted, and who laid the groundwork for the next grand chapters in Earth's history. Their resilience shaped the world we know today. The ocean is quieter now. The vast reef systems of the Devonian have crumbled, many of the great armored fish are gone, and the shallow seas that once teemed with coral towers and swirling schools of fish now lie half-stilled beneath gray, nutrient-rich waters. And yet, here in these shallows, in murky lagoons, tide pools, and freshwater streams, life persists. You wade through a silty channel where sunlight barely filters through suspended sediments. The water is warmer here, shallower and less stable than the open seas. Yet it is exactly this kind of environment that becomes a refuge for the survivors. In the aftermath of extinction, it is not the biggest or most dominant that endure, but the adaptable, the hidden, and the resilient. Near the muddy bottom, you spot a coelacanth drifting slowly through the stillness. Its thick, lobed fins paddle gently, propelling it forward with an ancient grace. This fish, nearly unchanged in its design, will vanish from the fossil record after the Devonian, only to be rediscovered alive in the 20th century, hiding in the deep waters off the coast of Africa. A living fossil. But now, in the Devonian shallows, it is just one of many survivors, quietly moving through a recovering world. Above it, lungfish breach the surface, gulping warm, low-oxygen air. Their ancestors once relied on gills alone, but in this oxygen-depleted era, lungs are a lifeline. You see one lungfish nestled in the silt, half-buried, its gill covers fluttering lazily. When drought strikes or waters become uninhabitable, it can dig deep into the mud, encase itself in mucus, and sleep through the dry season, waiting, patiently, for rain to return. These are not just adaptations, they are strategies, evolutionary blueprints etched in survival. You kneel by a stream that meanders through a thick tangle of fern forest. Insects buzz softly in the warm, humid air. Primitive dragonflies with wide, stiff wings glide from one reed to another. Beneath the surface, a small, flat-bodied tetrapod creeps along the stones. Its legs are stubby but strong. It lifts its body with effort, dragging itself from the water into a moist bed of moss and root. Here, in these transient places, between water and land, between drought and flood, life finds footholds, and the creatures who inhabit them become pioneers of Earth's future. In the absence of large marine predators, ray-finned fishes begin to expand into new territories. Though they suffered losses during the extinction, they now fill ecological roles left behind by the placoderms and many sharks. With their light bodies, efficient jaws, and delicate fin control, they move quickly into river systems, inland seas, and brackish estuaries. Some evolve specialized teeth for scraping algae. Others develop filter feeding techniques or ambush hunting strategies. The incredible flexibility of their body plan allows them to explore niches that have been left open in the Devonian collapse. You watch a school of these fishes, slender, silver-bodied swimmers, move like a ribbon through a shallow lake. They navigate submerged roots and reeds with ease, their eyes scanning for insects that fall from the overhanging plants. They are alert, quick, and perfectly suited to their world. Back beneath the surface, the early sharks continue to evolve. Some develop long, whip-like tails and strange dorsal fins. Others become flatter, hugging the seabed like the future rays and skates they will one day give rise to. Though many shark lineages vanished during the extinction events, a few quietly persisted, and those few will give rise to an astonishing diversity in the coming ages. Even the trilobites, though greatly diminished, still cling to life in certain pockets. Some evolve into burrowers, others into scavengers that live in the detritus-rich mud of deltaic systems. Their numbers will continue to decline through the next geologic periods, but here in the Devonian's closing chapters, they are not yet gone. And on land, the forests begin to spread once more. You walk through a grove of Archaeopteris, the giant Devonian trees, their roots winding through loamy soil rich with fungal threads. Spores drift lazily in the air. Early insects creep along bark and fly between fronds. There are no flowering plants yet, no fruit, no grasses. But these early forests stabilize the land, shape the climate, and build the foundation of terrestrial ecosystems to come. Among the roots, amphibian-like tetrapods emerge from pools to hunt. Their bodies are stocky, their limbs strong. Their skulls show new joints, allowing them to lift their heads and look around. Some begin to develop more complex lungs and ears adapted for hearing in air. These creatures are no longer just visitors to land. They are becoming residents. You observe one such tetrapod as it rests beneath an overhanging frond. Its skin is thickened, its tail broad and muscular. It breathes steadily, nostrils flaring in rhythm. Its toes spread into the damp soil. It is still close to its aquatic roots, but it no longer needs to return to the water constantly. It has options. These options, these variations and adaptations, are the legacy of survival. They are the blueprint of recovery. In the aftermath of extinction, evolution becomes experimental again. New forms arise, new behaviors emerge. Life begins, slowly, to fill the emptied spaces. The world is quieter now, yes, but not lifeless. You listen to the breeze through ferns, the burble of a stream, the plop of a fish breaking the surface for air. In these subtle sounds is the pulse of a planet healing. The Devonian period is drawing to a close. It brought us fish with jaws, limbs with wrists, trees with trunks, and lungs that breathe the air. It gave rise to the scaffolding of the modern world. In the final chapter of our journey, we will step back, gently, and reflect on the echoes of this era. How the age of fishes lives on in us. how its innovation shaped everything that came after, how even in silence, its story continues. You find yourself on a quiet hillside beneath a pale Devonian sky. The world is still warm, still green, still damp with mist rising from a nearby stream. But the air feels different now, settled. You hear the rustle of leaves in the tall Archaeopteris trees, the gentle murmur of water weaving through stone, the occasional flutter of an insect's wings. You breathe in deeply. And as you exhale, you begin to realize the Devonian is no longer just a distant time. It is something you carry with you. You walk through the forest floor, past mosses and fern-like plants, and down to the bank of a shallow pool. The light dapples the water, and within it creatures swim slowly. Lobe-finned fish with muscular fins, lungfish rising for air, early amphibians resting near the edge. Their movements are slow and deliberate, but each motion tells a story you know because it is your own. You look at your own arms, your hands, your fingers. Within them are echoes of fins, ancient blueprints laid down by Devonian fish. The bones in your limbs, the humerus, radius, ulna, carpals, first took shape in water, evolved not for grasping or building or writing, but for steadying a body on the muddy floor of a tidal flat. Your spine, your rib cage, your neck, they too began here. Structures once used to stabilize swimming now support breath, movement, and upright posture. Even the curve of your jaw, the tiny bones in your ear, the very act of swallowing, all of it has roots in the great experiments of the Devonian seas. You kneel at the edge of the pond and observe a lobe-finned fish, perhaps a tiktaalik, lifting itself slightly above the water, its eyes raised toward the canopy. It is unaware of its place in history, yet in time, its descendants will walk the land, breathe the air, and evolve into forms far beyond what it could ever imagine. And among those forms, eventually, you. But the echoes are not just in your body. They are in every living vertebrate. Birds, reptiles, mammals, amphibians. The fish of the Devonian left behind a legacy of form and function that would ripple forward for hundreds of millions of years. Every step on land, every leap through air, every dive into deep oceans, all of it began with their bones, their lungs, their bravery. The forests around you, too, hold these echoes. The vascular systems of tall trees, the deep roots that crack stone, the leaf shapes that catch light just so. These innovations began in this age, in the Devonian soil. They changed Earth's atmosphere, reshaped the landscape, and laid the foundation for every ecosystem to follow. You hear the call of a primitive insect, see it glide between branches. In its flapping wings are the first tremors of what will become flight. In the soft soil beneath your feet, worms and fungi perform their quiet alchemy, creating soil, exchanging nutrients, preparing the ground for future fields and forests. You close your eyes and listen. It is easy to think of the Devonian as long gone, a chapter shut and sealed in the great book of time. But it is not gone. It is within the layers of your DNA, in the structure of your limbs, in the breath you take, in the forests you walk, the rivers you cross, the lakes you sit beside. The age of fishes ended over 360 million years ago, but its songs still echo in every vertebrate heartbeat. You rise slowly and begin to walk back through the ferns, past the trickling stream and beneath the towering trees. The sky is still warm above you, the air still thick with spores and memory. The Devonian world begins to fade behind you like a dream, but its story, its innovations, its silent revolutions, those remain. And so, we now return to the present, carrying with us more than facts or fossils. We carry the deep, rich history of where we came from. Let us now bring this journey to a gentle close. Hello again, dear traveler. You've walked with ancient forests, floated beside armored giants, and watched the first brave breaths drawn beneath the Devonian sun. You've stood quietly at the shoreline as life took its earliest steps onto land, and you've listened to the long silence of the seas as extinction reshaped the world. Now, as the Devonian fades into memory, you carry its story gently within you. The world you know today, its animals, its trees, its landscapes, even the shape of your own hands, was shaped in those ancient waters and wooded lowlands. The Devonian was not loud or fast, but it was profound. It was a chapter of firsts. The first forests, the first limbs, the first air breathers, the first steps into an entirely new kind of world. Even now, the bones of fish whisper through your movements. The air you breathe traces back to forests that once swayed in humid, fern-covered groves. The pulse of life today still beats with rhythms that began long, long ago. So rest now. Let the weight of time settle softly over you, like a blanket of ancient ferns. Feel the slow rhythm of the ocean, the hush of forests before birdsong, the steady, quiet persistence of life pushing forward. Close your eyes if you haven't already and let your breath fall into step with the world's own long, gentle inhale. Drift into sleep, carried by the currents of time, through the ancient, eternal waters of memory. And as you drift into sleep, remember, the story of our world is always unfolding, even in dreams.